So this is the second video lecture of classification of signal and systems. So in this lecture, in the first lecture I have already covered the introduction to signal system, then types of signal, elementary continuous time signal. This video lecture I will cover the representation of discrete time signals. Okay. So the discrete time signal is defined as defined as the discrete instant of time. As we already discussed that if it is discrete instant of time, then it is called our discrete time signal. Means it is not continuous. We are going with the index as said x of t bracket, that is the continuous time, when x of n, that is discrete time. So there are different types of discrete time signal. There are four representation. One is graphical, functional, tabular, sequence. So there are four types of representation. First one is graphical representation, functional representation, tabular representation, and sequence representation. So let we are going with one by examples. Let a consider a signal x of n is equal to x of minus 1. X of n we have to plot using the all the four methods: graphical, functional, tabular, sequential. Okay. So first graphical representation. Let x of n is given. X of minus 1 is 1, x of 0 2, x of 1 2, x of 2 0.5, x of 3 minus 1, x of 4, x of 4 is equal to 1.5. So I will make first, this is n. Okay. So 0, minus 1, minus 2, 1, 2, 3. So given x of 0 is equal to 2. So let this is 2. Okay. X of 0 is 2. Next, x of minus 1 is 1. Okay. This is x of minus 1 is 1. Then x of 1 is equal to 2. X of 2 is equal to 0.5. This is 0.5. Okay. X of 3 is equal to minus 1. Minus 1. X of 4 is equal to 1.5. So we will put 1.5. So this is the x of n signal. You can put this is the x of n. X of 0 is 2. X of 1 is 2. X of 2 is 0.5. X of 3 is minus 1. X of 4 is 1.5. X of minus 1 is 1. And x of 2 is 0. So this is the graphical representation. Second representation is our functional representation. Functional representation means you will write x of n first. So first x of n minus 1, x of n is equal to minus 1 for n is equal to, where n is equal to 3. Then x of n is equal to 1 for where you can see for n is equal to here where 1 for n equal to minus 1. Then x of you can see 0 2 1 2. So we will go for 2 2 for n is equal to 0 comma 1. Next we are going x of 3 minus 1 over. Now only two components left. One is 0.5, second one is 1.5. So 0.5 for n is equal to 2. Next 1.5 for n is equal to 4. 0, x of n equal to 0, otherwise this is for otherwise, all other cases it will be 0. So this is the functional representation. So minus 1 for n equal to 3, 1 for n equal to minus 1, 2 for n equal to 0 comma 1, 0.5 for n equal to 1.5 for n equal to 4, and 0 otherwise. Similarly we are going for our tabular representation. Tabular representation I will write here n, here x of n. Okay. So it starts from minus 1, so I will write minus 1. Next it is 0, next it is 1, next it is 2, next it is 3, next it is 4. Okay. So what is the x of minus 1? 1, x of 0 2, x of 1 2, x of 2 0.5, x of 3 minus 1, x of 4 1.5. I hope it is clear. Now So let a signal given x of n is equal to x of n we have to do. Okay, x of minus 1 is equal to x of minus 1 is our 1. Okay, then x of 0 is 2, x of 2 is 0.5, x of 3 is minus 1, x of 4 is 1.5. So if I, for my simple Cn, you can see here 0 then 2 is there. Okay, so can I write here simple in a table format so that easier for me, n x of n. Okay, so first minus 1 starts 0, 1, 2, 3, 4. Okay, so x of n minus 1 it is 1, 0 it is 2, 1 no value is there x of 1, so I have to write 0, x of 2 is x of 2 is 0.5, x of 3 is minus 1, x of 4 is 1.5. This is the tabular. So now I am going for sequence representation. So a finite element sequence with origin is 0 indicated by symbol, okay, that arrow mark, where the sequence x of n 0. So now you can see here minus 1 start 4 ends. So I will write the same here first, 1, 2, 0, 0.5, minus 1, 1.5. Okay, so in that, where is the starting location? It is at 2 point. So this is the arrow. Arrow means first location. So if a sequence written without this arrow mark, okay, then first symbol, first location is n equal 0. For example, I am giving x of n equal 2, 4, 6, 0, 8, minus 3. What it means? X of 0 is equal to 2, x of 1 is equal to 4, x of 2 is equal to 6, x of 4, x of 3 is equal to 0, okay, so not written, x of 4 equal to 8, x of 5 equal to minus 3, okay. So x of 6 is equal to 0, we can go so onward. So I think it is clear now. So elementary, we know that. Now discrete time, you know that for continuous time signal u of t is equal to 1 for t more than equal to 0 and 0 for t less than 0. Similarly, for discrete time sequence, unit step sequence, what? U of n is equal to 1. In place of t, we are putting n, u of n 1 for n more than equal to 0, 0 for n. So how to draw this? This is simple. This is n, 0 it is 1, 1 it is 1, 2 it is 1. If minus 1 all these things, it is 0. Okay. So this is that, this is u of n. Similarly, unit ramp sequence. What is unit ramp? For continuous, we are writing r of t. It is t for more than equal to 0, 0 otherwise. Similarly, here we are writing r of n, n for n more than 0. So how it will be? This is that n, 0, 0, 1 it is 1, 2 it is 2, 3 it is 3, like continuously going on. So this is r of n. Similarly, next one is unit impulse function. So it is denoted by del of n is equal to 1 for n equal to 0, 0 otherwise n. So this is 0. So 0 it is 1, other than that it is, this is del of n function. Next, exponential sequence x of n equal to a to the power n. Okay, so 0 to 1, if we go, it will be go like decaying order. If a more than 1, it will increasing. Okay, like this is the sequence. Sinusoidal means sine wave, we are represented by a cos omega 0 n plus phi. Complex, we are represented by x of n equal to a n e to the j omega 0 n plus phi. For a less than 1, mode of a less than 1, the amplitude of the sinusoidal sequence decaying exponentially, more than 1 increases exponentially. So now some problems related to del function or impulse function. So here, as I said, this bracket 0 means it will make it 1 and it will be. So it is given e to the 2n del of n minus 2. So at n equal to 2, I will get del of n minus 2 is equal to 1, otherwise 0. So now in this case, what I will get? Summation of n is equal to, we will put n is equal to n minus 2 is 0 means n equal to. So here it will be, answer will be e to the 2 into 2, it is e4. Next one is del of n minus 1 sine 2n. So what? Del of n minus 1 is equal to 1 when n minus 1 equal to 0 implies n equal to 1. So here when n equal to 1, if I put here, this will be sine 2 into 1, so sine 2. Next. So third one is summation of n equal to n square del of n minus 2. So del of n minus 2, here also check the limit also. N plus 2 means n equal to minus 2, I will get del of n plus 2 is equal to 2 is equal to 1. So it will be what? Minus 2 means here minus 2 it is existing. So it will be, so we put n plus of 2. So it is minus 2 whole square. It is 4. So it is del of n minus 1 e to the n square. So when n is equal to 1 or n minus 1 equal to 0, we will get del of n minus 1 equal to 1. So means n equal to 1 here, so e to the power 1 square, n now 1. So it is e to the 1 or e1. Next, del of n plus 1 power 2 to the n. So here when n is equal, n plus 1 equal to 0, del of n plus 1 equal to 1. So n plus 1 0 means n equal to minus 1. Here range is 0 to 5. As range is 0 to 5, we cannot consider here. So this will be 0. So our answer will be 0. Similarly, del of n minus 1 sine 2n. So when n is equal to 1, okay, n equal to 1, del of n minus 1 equal to 1. But here range is 2 to infinite, no 1 is not there. So here answer will be 0, because sine 2 into here, because you cannot consider that value. Next one is 7th question, x of n del of n minus 2. When n is equal to 2, del of n minus 2 is equal to 1. So it is equal to x of 2. Okay. So this is the last problem. A to the n minus 2 del of n minus 3. When n plus 3 is equal to 0, del of n plus 3 is equal to 1, implies n equal to minus 3. When n equal to minus 3 means it is minus infinity, so range exists. So here we will put n plus minus 3, minus 3, minus 2. So 8 over minus 5. Hope you clear also discrete time signal. Over next class we will start some operations on signals. Okay. So thank you for attending the class, listening the video lecture.